So the last piece of this final graphing unit is finding the area of a shape on a graph. And this is something that can be super difficult if we don't go about it in the right manner. It's actually very, very simple thing to do. Requires finding 3 or 4 little areas and then doing some sort of combination of them. All right, either adding them or subtracting them. So we need to know these two formulas, but they are on the formula sheet that you get for the Regents exam. Doesn't have much on it, but it does have these on there. All right, area of a triangle is 1/2 times base times height. Area of a rectangle is just base times height. Okay, there's basically two kinds of these, all right, that happen. If you have a shape that has a horizontal base and vertical height, or they flipped around like that, horizontal, vertical, base, and height, okay, you can just count how long each one is and put it in the formula. So if you had a triangle like this, it would just be 1/2 times 8 times 5, which is just 20. Okay, I could do the part, the thing I'm going to show you for the second one with this, and it would still work, and it's probably the way that I would honestly remember to do it the easiest, but you can apply a regular formula to a triangle that looks like this. Okay, it is for some reason missing the 2 dots on the corner there. I don't know why. All right. The other thing happens is when the shape's not sitting perfectly horizontally and vertically, it's tilted, which is going to be most of the shapes. The easiest thing to do is put it in a rectangle and get rid of the pieces you want. So enclose it in a rectangle and subtract out the pieces we don't want. What that's going to do is just give us rectangles and triangles to work with that are easy to do. All right. And it's also going to make it a pretty simple little process to put this together. So I've got a process there that says plot the points, enclose it inside of a rectangle, find the area of the rectangle, and then take out the triangles. So here's an example, missing a dot again for whatever reason. All right. So I had the triangle that's shaded in here. I'm going to shade it in red right now. That's the triangle I want to find the area of. So I enclose it inside of a rectangle. All right. And then that red area is the green rectangle minus the 3 triangles. Okay. So it'd be green rectangle minus the 3 triangles would give me the red triangle. Okay, that's how it would work. The rectangle is 8 times 6 base times height, which is 48. So this red triangle is going to be somewhere around half of that. All right, half is 24. So I'm thinking like maybe 18 to, it could be like up to 30, depending on how it's sitting in there. All right, but probably a little under half is going to be the most likely thing. Okay, so my 3 triangles, area of triangle 1 is 1/2 times 6 times 3, which is 9. Area of triangle 2 is 1/2 times 3 times 8, which is 12. And area of triangle 3 is 1/2 times 2 times 6, which is 6. So it's 48 minus 9 minus 12 minus 6, which is 18, 27. So 21, I think. Let's double check that. 49 minus 9, 12, and 6. 9, 12, and 6. 21. Right, so the area of that red rectangle is 21. Okay, no matter what the picture looks like, that's exactly how they always work. And these are not complicated to do. I just have to take my time and know those 2 formulas. Okay, notice I don't have any negatives on there. All right, with areas, I don't want negative numbers. All right, they're measuring distances of sides. With Pythagorean theorem, it was okay to use the negatives because the squared kind of nixed that problem. With this, you cannot use negatives. All right, it's the only thing ever that we're going to do with graphing that involves what appears to be a slope that we are not going to use negative numbers.